This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Tomasz, it's great to have you here. I'm leaving you at this stage with our attendance just to let you know, guys, that we will host a Q&A session afterwards. So if you have any questions, please remember them. Please keep them for the Q&A session, and I will be joining you with a microphone. Okay, Tomasz, great to have you here. Hello.
Good afternoon. I was introduced already, but I need a little bit explain you why this type of the topics. Because as you know, probably all of you are building the complex application. And everyone knows that, we need to start with the proper architecture, we need to start with the proper code structure, etc., etc. And we are always in the mess, in certain point in time in each and every project. So, during this talk, I will be talking about very technical details, about tools which can help in various areas of the complex application. So it will not be about the designing of those applications or how to write a proper class structure. It will be more about what we have in the toolbox, which we can use, and we can deliver our project faster. Okay, so we will start with the .NET Aspire and the Orleans, which are used for the two purposes. First of all, how to run the code in complex environment, and how to have an application which is default driven without writing too many details in our code, assuming that someone who create Aspire did this right, and we will follow it. So this is the first assumption. Second part, Orleans, why it's here, because we are always having challenge with the solution which are stateful. And if we switch to the actor model, it's brilliant, but we can build a stateful application, but then we are having the challenge, okay, but how to host it? And this is where Aspire will help us again. That's the fun part. This is purely .NET. Second part, okay, not everyone is using the best software stack in the world, which is .NET. Someone using Python, Java, or other strange languages. And then we have a small challenge. Okay, we have a different stack here, but we have the same challenges. Monitoring, how to measure SLA for our application. And we need a slightly different set of the tools which will help us in that particular area. So here we are talking about the .NET, here we are talking about anything. Of course, we do have less functionality, but still will help us. And the third one is, why we need to write a code? We have 2025, AI can write a code, right? Yeah. We will see how AI can help us, but we will focus on AI from the perspective of tools which are solving particular elements, not as a tool who will build an enterprise app, because I don't think that AI will ever able to do that, because it's far too complex. Okay, let's move on. What is that .NET Aspire? First of all, it's something which was developed internally in Microsoft. I worked for Microsoft for many years, and in general, the purpose for that project was to give the guidance to the product group how to start, what to do, how to build the code structures. And we have, as I mentioned, some defaults. We have the ready-to-use orchestration. We have the quite easy integration with other components like database queues and few others. We do have a developer dashboard which will allow us to track what's going on with our application. And obviously, we have the service discovery and easy deployment. Enough of the slides. Let's switch to demo. Okay. First demo is very simple, because I will show you the basic solution in .NET Aspire, which will do service discovery, service calling, and some telemetry. That's it. So what we have inside the .NET Aspire? First of all, we have the host. In that host, we do have the projects, which in fact are the projects from Visual Studio. And then relation between that project, and we are telling, okay, by the way, this UI will wait for those two APIs which are defined above. And by doing that, we are doing two things. First, it will help us if I click F5. It will run the host. So I am starting with the this solution as a starting point. He will run me the dashboard. He will run all the projects and automatically create appropriate URL and pass the information between the parties. And that's the very important part. Because look what is happening when I want to call application. If I have the very simple solution in my user interface, yeah, let's close it. I have this kind of the notion. Yeah, please call something which is either on HTTPS or HTTP. It's named like that. It's named like that. And this is done automatically thanks to two things that I inside the initial configuration, I do have the instruction that we have the reference between those parties. I have under the hood in the details of my solution, I will have immediately URL to my API, and obviously I can see it. And on top of that, I can do a very simple command, which is called, I will just open and I will not do anything, which is called AZD, which will automatically deploy that solution to the Azure or Kubernetes. That depends on you. So, and automatically, so I have the following. First of all, it's working. So if I will click on there and try to run it, I will have the beautiful test, which will call to APIs. So from the code perspective, it's very simple. I do have this relationship. I do have the framework for HTTP client. And then in the rest of my beautiful, very complex enterprise great application, I am simply using that as a normal API without thinking whether it's working on Azure or Kubernetes or my local machine. It's just working. By the way, we kill DevOps because we don't need them. Everything what is needed is written inside this initial orchestration layer. And if we have any dependencies based on that something, we will have, for example, automatic deployment for the cloud. So if I will switch here, I will switch to the Azure container environment. Inside this container environment, I will have a slightly more advanced go internet application. Yeah. And then I will have slightly different view, but the same concept. And I obviously have my beautiful application which I can run and see how it works. That's the first step. So we have the discovery, we have the calling. Third element is that small detail. If I switch to, let's switch to my local one. That one, yes. I have console which will show me the logs from the particular application, but also I do have the structure log which will show you that if I am calling something, I am calling different services each after another, and I will even have a trace which will dig into the details. What are the delays between the calling elements? And by the way, I didn't do anything to have it, just turn on defaults from Aspire. So that's the kind of the blueprint of each and every application. And imagine that you need to write it from the scratch. Okay. So that's all. By the way, what I need to do telemetry. That's also quite nice, because from the application perspective, I have something which is called the service defaults. Inside the service defaults, I have the simple extension which is using Open Telemetry and Open OTLP exporter, which then can be captured by this Aspire dashboard or Zipkin or Jagger or application insight on Azure or whatever local analytics you want to use. So technically, again, we have quite nice environment to run this beautiful application. That's enough. Let's move on. Okay, we did a very simple application, but now the question is, okay, but how we will tell the environment that our application is working? In the simple client-server world, we do have the very simple mechanism to do that, But if we have a dependency between the many layers, microservices-like style of application, then this simple question whether our application is working or not is not so simple to answer. But again, in Aspire, because here we have a slightly different elements on top of the previous orchestration which you saw on the previous example. I have first information that I want to have this API on 2 replicas. Each replica will have their own health check, and then this something when I run this application, you will see, and I hope that I will click fast enough because it will be failing for some time. Yes, wonderful. Yes, running unhealthy. Why? Because it's waiting for these health checks, which technically are REST APIs, which needs to return 200. Everything is fine. And one of those functions is simply randomly failing, and second one is simply waiting for the delay. So that's how we can build our very complex health model. And then automatically, because we do have the dependencies between those models, this web UI knows that it's waiting on this API, and therefore, well, because that failed, this one cannot be started or is not working properly. And I imagine the tree of the components, which is far more complex, but you will see how it works. And also, I add here that I am waiting for previous service to be run. And then, obviously, I mentioned that we have the classic logging built in, but we can extend that. And for example, we can do something like that. Add to this service default some additional elements, which is very simple, because what I'm saying, that I am using classic .NET based activity monitoring. Nothing uncommon. So I am doing them normal metering, normal activity source, and then I am registering this as yet another source of the information for my application. And then obviously, if I do have the processing, because I have the where is that processing engine? Where I put it? Oh, here is worker. Inside this processing engine, I have the proper tracing, but I'm using here only logger, nothing more, nothing uncommon. So that code doesn't know anything about being run inside the Aspire. That code is using classic .NET monitoring environment and whatever you are doing. And by adding only that small part of the code, automatically I got. Huh? I have an error because it's failing all the time. If I switch to the structure lot, you have the all the information. And if I switch here, you will see that some traces are coming from the processing engine or from other sources. I don't have the time to dig into that, but I think that you have the ideas how to trace it and how to execute everything what you want to do. Here is nothing because here we have the aggregated version. Obviously, if we can have some information about too long the duration of the things which are calling. That I have the information that health controller returns something wrong, and that's for free on Azure, on cloud, on any Kubernetes like solution. And obviously we do have the same in the cloud, because if I switch here, I have the same traces here running on Azure Container Apps without any problems. Okay, let's move on. Yeah, great. How to deploy it? And this example is a fake one. Sorry for that, because I will not deploy this on my local machine because it will take too much, because it will take about 4 minutes. I don't have it. But I will show you the source code of the solution which is using. SQL Server, Postgres, some database queues, and few other elements. What is that? Oh yes, here, database. Wonderful. And here, as you will see, automatically I can tell what are my expectation for services which can be provisioned either on my local machine in Docker containers, or on Azure, or in both. Because, for example, I can have solution like that. Where is it? Yes, Progress Flexible Server, which will be running always on Azure. And by default, in app settings, I will have my credential for my development Azure subscription, that those resources will be created on that subscription and connected to that my particular code, which will be using that that subscription for software development. So from the deployment perspective, if I switch to the Farm Manager, which I need, and go to the C folder and go to this one, you will see that I have here the configuration for Azure, which is config, then the environment, some parameters, and all the elements which I need. And then everything what I need are two things. First is something which is called AZD infrasync. That's for the case when you are when you deleted all the resources from Azure without running properly AZD down. And then I am doing the AZD up, which simply will deploy this to the cloud. So remember, that's why I'm showing this, because from the development perspective, it means that developer is responsible for the end-to-end environment. Don't rely on some IT administrator, DevOps, and others who are dealing with the whole environment they are needs for running the solution. And at the end, they cannot tell that it's not working because of that guy. No, because it's not working because you did the mistake somewhere in this orchestration, or you did something wrong there. And at the same time, it's very, very easy to move the code between the Azure and okay. Another example is beautiful because I show you the stateless solution. In stateless world, everything working as expected. But what if we have the stateful project? Because we need to run multiplayer games, we have a smart city project, we run the hospital information system, or whatever, where we really have the session, we have the multiple user, to that session we are adding information. And we need to manage solution like that without having too much trouble. And in general, Orleans was created in 2014 together with Hello Game. And initial use case was real world for the game, because we need to have the gamers who are moving inside the world. We need to have the agents who are moving inside this world, and something needs to keep an eye on the whole environment. But then it became part of the .NET few years later, 10 years later, and at the end we are running the quite sophisticated actor-based mode. Just to give you the short overview about what is the actors and why it's quite interesting. We are moving into the world when we have the class. Class will have the identity. That identity is connected to the instance of that particular class. And then this environment, which is called the silo in the Orleans, hosts those grains and allow them to communicate between each other. So technically, if I have the class A and class B and they need to talk to each other, the only thing which is needed are the numbers of those classes. We don't care where they are hosted, whether on the same server or on the other one. But we know how to call them, create them, and pass the message between the classes. Technically, our actor lives forever, but can live outside of the memory. And if someone will call actor number 10, then this actor will be resurrected and bring back to the server environment. Obviously, we can move the actors between the servers, and that is very powerful things because in the latest Orleans, I don't have time to dig into the details, but it will allow you to optimize the usage of the server. You can either fan out it between the all machines or consolidate to the single one to turn off others. But everything without impacting your logic flow of the solution. Obviously, we have the RPC-based interface, but those are the details. Other quite interesting features in the Orleans. First is the persistence, because you can save, restore the data from external storage. We have the ready-to-use publish-subscribe framework, which is quite easy to be integrated. We have a scheduling engines. We have the push notification, so actor can call another actor from the middle of the calculation just to inform about the progress. And we have full transactional support, meaning that we can have multiple actors which are running on different servers and doing distributed transactions, which is also handy in the stateful solution. But how it is connected to the Aspire and the integration there? Aspire is taking care about everything what is related about the hosting silos, exposing the host, connecting client to the host, monitoring obviously the whole environment, and again we can run this fully on our laptops, on Azure, on Kubernetes, wherever we want to deploy that. And technically, everything what we needed is to add a few elements to our orchestration program.cs, because we need to add the host and tell him, okay, we will use the Redis as our clustering engine, which will synchronize the separate hosts. And then we have the project, and from the client, we simply need information where to find this information about the cluster. So this app host which is running our software. So from our perspective, it's quite easy to run the program, because I hope that this time, yes, Orleans, yeah, because this time we will have the Orleans running here. We will run the Aspire application, and our beautiful application will simply start the few elements, running, do faster. 2 grains, so 2 hosts for the solution, and then starting, please. Yeah. Okay, and then I can do the counter, which will simply test. I am passing here the name of the grain, so in that case is test. I am asking client for grains, give me the instance of the grain which is called test, and then I am calling increment method, and that increment method is inside my my grain, which will do anything what I want, and of course save the state. And from the code perspective, it's quite easy, because I'm saying, okay, we will use the persistent state, we will save it by calling the proper method, and that's all. This is also very simple from the I know, because I spoke too slow, and I need to do this once. Okay, nevertheless failed, so let's switch to Azure. Just to prove that it's working, but I hope that you understand the concept, because the goal is not to show you the beautiful Orleans, but just tell you that you have this functionality as a part of your toolbox, which you can simply use. But I want to show you that the same code will run here, and yeah. Now, second one, this is a different grain. Now it started to run. When I switch back to the previous one, we'll go start counting from the because we are calling different grains each time. Easy to program, easy to host, easy to solve stateful challenges, let's be honest, but not very popular. I don't know why. Because well, it's quite easy because people prefer to have the static method in the class and then have small challenges with that later on. Okay, let's move on and let's switch to the what if not everyone is using .NET, and we have the Python, JavaScript, and other types of the solution. The concept was created, I think, in 2016 as a sidecar next to the container, which will take care about certain aspect of the solution. Initially, it was only the service invocation and state manager. Later, we add another actors. Later, we add workflow. And now it's CNCF compliant, independent from Microsoft project, which simply exposing from sidecar on local host certain set of the APIs which can be called by your main application. So the Dapr approach is the following. Okay, my application grow. I need to have multiple components, but I don't have enough money to rewrite everything from the scratch. I want to put something on top of it, which is not on the infrastructure level like service mesh, but it's more on the software level. We will change only the way how we will call our services, and that's it. And and then obviously we built an, I would say, interface layers between different functionality in different providers. This is another huge benefits from using Dapr. And at the end, we can rely on this local interface, which we are simply calling. Because how the application is talking to the this whole environment. It's calling on the local host on the Dapr sidecar port, what they want to do. That's something is doing different things. It can call another service, that would be the service invocation, can save elements to the state storage, or save something to database. Depends on your need. But from the application perspective, I'm only talking to my local host. Rest is a Dapr configuration. That's also powerful, very. Especially it's between the languages. So in general, if I would like to compare that Dapr to Aspire, it's a wrong comparison, but it will tell you a little bit about the different purposes. .NET Aspire is purely .NET, and it's focused on giving you the blueprint how to build the solution. Dapr is like making the grass more green. It's let's add something which will solve certain areas of the challenges, and then our solution will be better because it will be obviously better. But I want to start with something very, very simple, and I will start here, because what we have here, I hope that you are seeing this correctly. I have the simple YAML file which will tell you about the Dapr application. One is the API, another is a client. I am exposing Dapr HTTP port 3500, another is 501. Because I am not running this even in the container, I am just running this as a processes on my machine. I don't need the containers for such a simple demo. Both are written in Python, and what is also important is from the API, do not laugh at me, but it's a simple Flask post method. And client is more interesting, because client is asking, give me that port, and then call that method, which is called data, as in this my previous code. So I am not binding together two things, but I am having this indirect level called the application name. So if I run it, the running this locally is as simple as .run -f dot, which will load the YAML file locally. I will have 2 processes, and no, 4 processes. 2 for Python, and then for each Python sidecar, which allow you to communicate with the particular Dapr services. So if I have it, then I can either call directly Dapr API because I know where it is hosted, and then it will be executed, and then that Dapr will call another service, which will be this my API. So I have the client, external client, who call first Dapr client, which call API implementation on the next level, and everything is done on very simple layer, on the very kind of the configuration layer. I'm just telling which type of the services you need to use, and in the same way you are adding additional services for the states, saving state, for the databases, for the queues. Everything you are communicated with very well defined API, REST-based API on the local host done by sidecar, and that sidecar will call whatever else it is. From the Aspire perspective, it is something like that. Because if I want to expose Aspire as a Dapr, the only thing which I need to do is to add Dapr sidecar. And then automatically .NET application became Dapr application, and you have this ability to call and call functionality directly from the other Dapr components through Aspire. So it's quite nicely connected, quite easy to integrate, and quite useful in case if you have AI-based solution, which is usually written in very slow Python, and then we need to live with that. Which moves me to another topic, AI. Because we have 7 minutes, it's enough to talk about AI. And I want to focus on two things. First, how to use large language models inside the application, and how to make the application portable between the different LLMs. Because you can assume that if you started a project, I don't know, now, you use GPT, I don't know, 4.1, you will finish project with GPT 7. And you need to have the easy way to switch that model, because those models are better and better as times flow. And I am using here something which is called Semantic Kernel, which is simply .NET framework for dealing with the large language models. Okay, let's close it. Let's switch to that demo, and let's see how it works. Okay, from the environment perspective, it's very easy. I added a Semantic Kernel library, and then we will do some calculation. Why calculation? Because LLMs are very bad at it, and our goal would be to tell AI engine to tell us that for the simple multiplication, that model needs called different function, kind of native function, instead of trying to solve it using large language model, because it's not designed for that at all. Okay, so okay. Sorry. First, let's close it. Because our goal would be to execute certain type of the calculation, we need to tell our model what are the capabilities which we are giving them. Those capabilities in Semantic Kernel are defined like plugins, and those plugins could be either like functions. We need only to describe, because LLMs works on natural language, on English language, which in that case, or in Polish, we'll see it in a moment. Or it could be something which is defined as prompt, which is simply trying to get intent of the action from the user, or get the number from whatever user will tell us, and then our prompt is different. But from our code perspective, it's plugin which we need to load. And then we are defining agent, and we are asking them first element. Okay. I ask that model to add the two numbers. Yes, not yet. And then it automatically told to us, so we ask model to add two numbers. Model respond, no, sorry, for adding numbers, you need to call normal function. And I will tell you how to do that. So model told us what to execute from our code. And automatically we are having the function name, which will do the square root in that case, will do the calculation, and then we can call it and respond. And then obviously we will have this method called. And from the response, we have the match plugin, which is what is the square root of 634. And then we have the conversation, we have the response from our native function. But this native function was called only because LLM told us to call it. So model is telling us what to do. Of course, we can automate this a little bit more, and we can say the same comment, but here I enable call that function automatically without even my code. I just register the operation which you want to do, and then if I run it, yep, you will see that automatically it detected, okay, I need to call that method, and call it, get the response, and we have the beautiful response, this time a slightly different, because those are the stochastic models, so it's not predictable. You will not get the same forms, but you have the same out. Okay, let's move on a little bit more, and we will have a little bit more fun with these LLMs, because the fun is starting right now. Because we are adding mathematical plugin and time plugin. Time, LLMs can't answer what day is now. Because now for them means when I was trained, where the cutoff time happened. But if I will tell them that I will have the method called time, which will return the current hour, current month, or whatever, then model will discover that, he's asking me about the current data, so I know how to extract it. And from the solution perspective, we will simply call it. And now we are also doing something different. Look at the question. Calculate square root of 64 and multiple result by 2. So LLMs needs to tell us that he needs to call two different methods to achieve that goal. And if I move on, you will see that if I call it, automatically square root as expected. Oh yes, multiple. And automatically pass the 8 and pass the 2 based on the prompt and the result of the previous calculation. That is done automatically by model. And semantic kernel a little bit, which is simply orchestrator in that case. Well, look at that. Odejmij od 15 liczbę 3. It's not a number. It's 3. So it's written in the word. So in that case, it used additional services which simply transfer this 3 to 3. But it was done again automatically, and we are getting the proper output for that equation. Again, 3 and then adding 2, more complex equation, and the last one, we are adding to the final number current month number. So we are calling two different methods, and the output is correct. And you will see in a moment, it's asking, okay, what is the current month date by ELM? So, okay, I have 24 seconds. Great, according to plan. I hope that you understood why I am showing you LLM in that way, because you can build every of those solutions by hand, but it will take at least 2 months. Here, it's simply combination of prompt, semantic kernel, and the proper way of the function calling. That's it. And you save a lot of time and a lot of the energy. So in general, during this talk, I tried to start with the very simple overview of the .NET Aspire for the hosting, Orleans for saving the stateful challenges with the stateful application, then how to deal with the other languages and how to use that, and then how to combine everything with LLM. Thank you very much.
Thank you very much. Do we have any questions for the Q&A session? I don't think so. Everything's clear. That's so good. Great. So thank you very much. The leader of our community, Paweł, joining us on the stage to present our speaker with an award. Thank you so much once again.
Dziękuję bardzo.
You should get a super award for being
Dobrze.
so on time. Yeah.
Dziękuję. Logiem do przodu. Dobrze, będzie logiem do przodu.